Hi everyone, so this is Nikhil. I have been working at Flipkart's developer productivity team for past 3 years. So today I'll be talking about the platform that we have at Flipkart, which is built over last 4 years, and challenges we faced during while building that platform, while taking it to that scale, and how we solve them. So the general agenda of this talk is, first of all, I'll set the tone by talking about general usefulness of CI/CD. Then I'll do a quick demo. After that, we'll talk about flow, its architecture, so that you have context on the challenges we faced and why we faced those challenges in the first place. And then we'll talk about the optimizations that we did to mitigate those challenges. Okay, so let's start with the usefulness of CI/CD. So it's 2025, and we know essentially why an organization needs a CI/CD. First of all, you don't want a single guy to have a set of SSH scripts that are there to deploy or build your code, because others cannot pitch in it, and it is a bit complex to understand at other levels. So that's why we codify that wizardry into pipelines. Another thing is that you should be able to build and deploy in one step, so that every incremental change is built, and code is always in a deployable state. When you can when you can deploy incremental changes, you get a shorter feedback loop, so you can iterate on things very fast. Now, these are essentials of a CI/CD platform. What are the extensions if you have a central platform? So you can have productivity metrics for the whole organization, and then as a team, you can work on improving those productivity metrics. You can add governance. Think of a sale where you need to do a code freeze so that people don't deploy as often to reduce outages. You can have audit for every action. You can restrict access to production and it is governed by approvals. And you can have third-party platform integrations, because once you have a central platform, think of, like, we have a new platform created recently in Flipkart that is called CodeLift. What it does, because it knows that there is a CI/CD definition written somewhere in a central platform, it automatically raises a PR for any repo in Flipkart by bumping up its Java version, because it has recipes to go from Java 8 to, let's say, Java 12. It will raise a PR, and as it can trigger a pipeline using the SDK of our platform, it knows if the pipeline passes, then its changes are successful, and then it saves a lot of toil. So you can, once you have a central platform, you can build a lot of integrations on top of it, which maximize productivity. Okay, so let's just start with a quick demo so that you have context on how the platform looks like, what I'm talking about. Then we'll jump on to the challenges. So for this demo, I have, this is a pre-recorded demo because I only have 30 minutes, and I'll be talking at this pace. We'll discuss things in detail in Q&A if I left out anything. So for this demo, I have a to-do app for which the change that I'm going to deploy is adding a background to that app. So this is the background that I've added. This is the app. I'll quickly raise a PR, and it will trigger a pipeline on flow. So this is the entry point to the platform, the flow that I'm talking to. So here you'll see that it has triggered a pipeline. Now a pipeline looks like it has a clone step, which is cloning the repository. Then it is a package step, which is pushing the deployables, the Docker image and the Helm chart for the service. Now there is a new thing that So wait, yeah, I think this pressing space bar resets the demo. I'll just use the mouse. So the thing you see here, it has triggered the pipeline. Yeah. So it is cloning the repository. Now it is building the deployables. Now you will see that how someone would create such a pipeline. So what we have done here, we have a catalog in the platform itself, which has managed templates. For example, these are the managed templates. They have the script, they have the environment and parameters to do anything. If you want to create a pipeline, you just use these templates as a building block. What it helps us do is, if you want to bump something, if you want to, let's say, remove some dependency from our build environment, we can do it here, and it will percolate to all the pipelines altogether, and no one has to do anything else. So that is how, that is how these pipelines are built. Now, there is a new step that I think most of the pipelines don't have. It is called dev deploy or environment deploy. So it will create a brand new environment. It will create and install my service there. This is not stage, this is not pre-prod or prod. It is a new environment which will have the service, and it will give me a preview of my service. So you see this service, it is deployed in an environment that is just created by the pipeline, which will be deleted later on. Why is it created? It is created to run integration tests. So you can add further steps to it so that other services can quickly find this IP and run integration tests on it. While these integration tests are happening, I'll just show you one more concept that is called deploy candidate. So the artifacts that are generated by a pipeline, you can see all of them at one place in the project. And these artifacts, they are certified by Flow. So if an artifact is a dev candidate, it can only be deployed to dev environments. It cannot be deployed to prod. Because how we achieve it is, dev candidates are stored in a registry which doesn't have connectivity to prod environments. Once a pipeline completes and changes are approved, PR is merged, then these candidates are promoted to release. So they are moved to a registry which has connectivity to production clusters. And that is how you can add governance, you can add certain checks. For example, you can add a quality gate. For example, recently we have introduced a new quality gate in Flipkart that is every change will have to have 80% code coverage. If any code doesn't have 80% code coverage, it doesn't go into production. And there is no other way to deploy anything without that. We have a break glass feature as well, because there are some changes that might require emergency deployments, but you cannot deploy routine changes without a coverage. So my PR is merged. Now my candidates are promoted to release. Now I will deploy them. So again, I've come to Flow. I have clicked on a deploy pipeline. You'll see that Flow has automatically selected the candidates that were just created, and I didn't have to do anything. Now, in the pipeline itself, it has all the things that are required. It has the reference to the cluster that I'm trying to deploy, so it is a production deployment. And here I'm selecting the strategy that I'm using to deploy. So here I'm using a canary strategy, and it has two phases. First phase is, I think it's not visible at the back, but first phase is 10% wait, then pause, then 60% wait, and 60% traffic, and then pause for 10 seconds. Because it is a production deployment, it will trigger an approval. And here I have raised an approval request. Once this approval request is raised, Flow creates a release note of all the deploy candidates that are getting deployed. Because what we want to do, we want to maximize the context in every decision you take. If anything is going into production and you are the one who is allowing it, you should know all the things that are there to know about it. So this is a release note or approval note that is created. So here is only one artifact that we are deploying. And you will see the cluster it is going into. You will see the change log, like whatever commits went into this. You will see the PR for it, Jira tasks, and other things. If there were any policy gates it passed through, you will see all of them. Now my pipeline is approved. I'll proceed with the deployment. And once my deployment is done, I'll go to the release page. So deployment is done. I'll go to my release page. One thing you can see here, I haven't left Flow. The only thing I'm touching here is my editor, GitHub, and Flow. I'm deploying on Flow, building on Flow. Even I'll now monitor my deployments on Flow. You see, this is a canary strategy, and there is only one pod that has come up. Other 3 pods are in the older replica set, because the first step that I had was 10% traffic until after that an infinite pause, so that I can promote the rollout. And not just the strategy. At any point, if you realize your deployment is going wrong, you can pause and play your deployments like you play a movie. You can do that. And here, all the phases have completed now. Now, if any point I think that, okay, I don't want to go with these changes, I want to abort, I can click on abort, and it is not a simple abort. You will see that it will show you the diff that you are aborting to. So whatever is in green is the changes that will come up. And Flow is also running some validations that I will talk about later in the talk. So so that if anything is going to go wrong without you paying attention, Flow will catch those errors. So now nothing is going to go wrong because these validations are passing, and it will let me abort it. So I want abort the changes for the talk. And once I close this dialog, I'll open the app, and my changes are deployed. So just before closing the demo, I'll do one more deployment. That is a config-only deployment. So config-only deployment means where you don't build anything, you are just doing a config change. At Flipkart, we use it for doing DC failovers where you have to do things immediately. You don't have to wait for the pods to sync or anything. So how do we do that for this app? The config changes, changing the title. So if I change my config, title in the config, the title changes. I have pushed my changes to GitHub. As you notice, I have come to the deploy pipeline directly. I haven't gone to the build pipeline. And now what will I do? I will select this config only button here. When I select it, deploy candidates disappear, because now Flow will determine what was the deploy candidate combination that it used for the last deployment in this cluster for this release, and it will take them and apply the updated config. So that is how the config-only deployment works. You just run the deploy pipeline by committing the changes to GitHub. Flow reads the config file from GitHub. We also have another service that is called config service that is for more involved configs, but for this demo, I'm using the GitHub config file. Okay, so I have deployed my changes, and it is fetching the config file from GitHub. Now, when my changes are done, the release is updated like 14 seconds ago, and you'll see that pods haven't restarted. Anything hasn't happened yet. Why? Because the service that I'm showing for the demo, it reads the config on startup. It doesn't poll the config. So there can be services which might be reading the config on startup. So what we have here is a restart button, which will restart your pods one by one. So my app hasn't changed yet. The name hasn't changed yet. What I will do, I will restart my rollout. Now, how it happens is it will acknowledge your max unavailability. So at one point of time, one pod will be unavailable, and it will show me what all pods don't have the, I don't know if you can see it at the back, but there are pods that are in dark green color. It means they don't have the updated config. They are pending restart. So I'll just fast forward the restart process. And once the restart is done, I see my updated app. I see the updated name. So that is how config-only deployment, and simple build changes works. Now, one more thing. How many of you have used Helm here or use Helm in your organization for deploying to Kubernetes? Okay, a lot of you use that. So you know that Helm comes as a package manager. It gives you revisions and everything, but you have to use CLI for that. So we have integration on top of that, which will not just do rollbacks. It is guarded by a lot of API glue to do validations. So you will see these are the validations that apply on this release, and they are context-specific validations. They are not just static validation. They will look at the environment, they will look at the release, and then they will be applied. So here you can add validations, you can add blocking rules. If you want someone to move to a newer SDK, you can block their deployments. Now, one thing here is you can come here and directly see the difference between whatever you want to revert to. This is the first page anyone comes into Flipkart. When they see an outage, they come to this page. They see what is the different thing that has happened. What is the change that has gone through. For example, for the last deployment, the change that has happened is the config change. I have changed my to-do list from the new list to new list. So that is how it works. Now, there might be times where you want to roll back to a certain state of your app, but from this diff, it might not be clear because the only thing that has changed is the image name. So we again provide the release notes here just to maximize the context so that you know what you are reverting to. So that's with the demo, guys. Now I'll quickly close the demo and I'll talk about Flow. So Flow has been in 4 years in production. It's also 4-year-old only. I joined the team when it was 1 year old, and there were a lot of capabilities that were not there. We were just doing simple builds and deployments. Right now, it is deployed into 3 data centers. We clock 8K plus builds daily. It has 6 million pipeline runs that have happened in the past 4 years. And the cadence that we have is today, Flow does 1K plus production deployments daily 1K deployments. Now, what were the goals for creating Flow? First of all, we wanted to move to Kubernetes in 2020 because managed Jenkins for every team, siloed Jenkins. There was a lot of maintenance that was required, and uptime was not that good because if one Jenkins goes down for a team, then they are stuck until that comes back up again. Another thing, when you have a central platform, you can manage dependency very easily. You can free up bandwidth in teams, and they don't have to know a lot about things like Helm or Rollout because those things are abstracted for them. Then we wanted to restrict production access, of course, because uh, it's production, and we want to also, for example, if there are if there are big billion day sales, then we don't want to want to deploy that frequently. If things are stable for 1 week, let them be stable. So we want to add code moratoriums, have deployment markers so that incident teams can latch onto that. Then if you have a lot of metrics, if you have a central platform, then there are other platforms you can build around. So these were the goals. Now I'll quickly talk about the architecture so that when I talk about the challenges, you know why we have those challenges. So this is the worker pool architecture. So we have a worker pool which is responsible for executing those pipelines. So a worker pool has a set of Kubernetes nodes. In every node, there is a Docker daemon and a lifecycle manager. What Docker daemon does, it facilitates Docker builds. Lifecycle manager cleans up the repository and other artifacts that are there. Because if you build 8K services daily, there is a lot of disk gets used up very quickly. So you need a lifecycle manager that intelligently clears everything up. Then we have a workflow controller, which is used to translate the pipelines you saw on the UI to actual pods on ground. And then we have a logs relayer that release logs to the UI. So this worker pool is how Flow achieves scalability and cross DC installations, because when you want to scale Flow, you can add nodes to the worker pool, or you can add a newer worker pool in a newer data center, and control plane can sit anywhere. So whatever you're seeing in the white is the control plane, which I will not be talking much about, because the challenges, because this is just a lot of API glue that we have that you can also come up with. Now, this is, here we are using a workflow controller that is Argo Workflows, but the stock is not about Argo Workflow or Helm. You can use any, for example, you can replace this with Tecton. This is more about the structure we have put around these projects. Okay, so this is how the pipeline that you saw earlier gets translated. So the clone step, it will become a clone pod, build step will become a build pod, which will have its own image and the script that it will run based on the parameters. The important thing I want you to show here is that all these pods, they are getting scheduled on a single node because they have a shared disk. Why they have a shared disk? Because the build pod will create an image, build pod will create a binary that would be used by a Docker image, and there are artifacts that have to be passed around which are large in size, which you can't do using bucket storage. That's why we have a shared disk here. Now, because we have the shared disk, there are certain challenges that I'll talk about. Now, how our environment creation step works, it talks to an environment cluster, which is there just for use and throw environments. It will create new environments and then install services in it. This is a separate cluster. So again, this can be scaled separately. Okay, let's talk about the challenges that we faced and how we solve them. So first three challenges, scheduling, slow pipelines, over provision, they are build challenges. And the rest of the two are the deployment challenges. So the first challenge, scheduling. As you saw here, that all of this is on a single node, and a whole pipeline has to be scheduled on a single node. Now, if you have a large number of nodes, if you have 20, 26 nodes, how do you determine where this pipeline would go? When Flow was in its early stages, like first year, we used to round robin the pipelines. Like we'll select a node randomly and then assign a pipeline to it. But some pipelines are fast, some are slow. So there might be times where a node is not freed up quickly and your round robin algorithm doesn't work. It worked well till 2K, 3K builds daily, but when we hit 4K builds, when more teams started using Flow, we stuck into unschedulable issues. Pipelines were pending for a long time because the node that they are assigned to is not available. So how we solved it? We did some analysis and realized that 90% of pipelines run in under 10 minutes, and 10% of pipelines take anywhere from 15 minutes to 1 hour. So, but the main observation here was that long-running pipelines don't run that frequently, but short-running pipelines are run very frequently. So we partitioned our node pool into two pools. One is for short-running but frequent pipelines. Another one is for long-running and less frequent pipelines. How it is calculated that a pipeline will go into one of these two pools is via a score that is property of the frequency of the pipeline and the duration of the pipeline. If a pipeline becomes faster, it automatically goes to the short-running pool. So that led us to go from 4K builds to 8K builds on the same hardware without adding any extra nodes. And we don't see schedulability issues anymore. So the another issue is slow pipelines. For scheduling, we also tried one more thing because we didn't want to get into scheduling. We tried NFS. So on GCP, we used NFS, but NFS didn't work that well because NFS has slower I/O times than the local disk, and slower I/O times eat into the speed that we got. I think mic is choppy, but yes. So we didn't go that well with NFS, so we don't use NFS anymore. We 20% of our pipelines are scheduled on NFS. Now let's talk about the slow pipelines. So pipelines, mostly build pipelines are slow. Deploy pipelines don't take that much time. So what we first of all in October 22, what we saw that our Docker builds were taking a lot of time. How we solved that? We started adding we first of all we changed the builder that we were using. We moved to BuildKit and then added a remote layer cache. So how does it work? BuildKit will push a remote cache to JFrog, the registry that we are using. It can be any OCI compliant registry. And then whenever an image is built, it pulls that cache. Why we are pushing the remote cache to JFrog and not using Docker daemon cache? Because when you build 8K plus images daily, the disk that is on the node gets filled up very quickly, and you cannot rely on that cache the next day because in the same day the disk gets full. So we had to clean that local cache up. So that's why we use remote cache. But what it did, it reduced the time by 50%. So it reduced the time in half. If something was taking for 4 minutes, it just took 2 minutes. So that is one win. Then we add, now there are build cache that takes a lot. There is a build cache that can take a hit if you have a multi-node cluster. For example, there is a pipeline that is building an Android app. If that pipeline goes onto another node, it won't have the Gradle. Okay. So I just have 10 minutes. I'll quickly finish it up. So if that pipeline goes onto another node, and I just have 5 minutes. Okay, sure. I'll still continue. So if that pipeline goes onto another node, then there is no cache to use. So what we do for a cache that is greater than 15 GB, that is greater than 5 GB, we pin the pipeline to a certain node so that pipeline and node has an affinity. If that node is not available, pipeline will go to another node. But till the time that node is available, pipeline will give a hit. Pipeline will be hitting the cache. Then if there is a pipeline that is generating cache that is less than 5 GB, we tar it, we push it to a bucket storage, min.io that is server adjacent, and then we pull it back again and recreate the structure when the pipeline is executed again. So that is only for cache that is less than 5 GB. Now the other thing, I'll just quickly run through this. So over-provisioning is one more aspect you should think about, because there are build problems which are not solved by throwing more cores or resources at it. So how we solve that is, first of all, the templates that I showed you, we use templates, source signature that is standard. For example, for clone step, you don't need more cores. You can do what everyone is doing. And we also put some metrics, and we track the unused delta. So utilize resource metrics we have, and we look at the requested metrics, and we track the unused delta. Now, these two issues are deployment issues, atomic updates. So all of you who use Helm, you know that Helm is a package manager, but what it doesn't guarantee is atomicity. Think of the times when you have 4 things to deploy that are packed in a Helm chart, and config gets a pod gets applied, but a config doesn't get applied. Now pod is seeing the older config. Helm doesn't guarantee anything. It will just say failed release. Now, how we solve, and there can be a service that is deployed to 10 clusters where each cluster has a different version of Kubernetes. So some API versions might have got deprecated there. How do you solve that? So we use kubectl dry run for all the manifests. So Flow does it automatically before you deploy. It will check all the OPA policies, all the version updates, everything. If dry run passes, then Helm install will succeed until there is a timeout. For timeouts, we do a retry. So that is how we guarantee atomicity. Then there is incorrect deployment configuration. You might ask that incorrectness could be caught by dry run. Why do we have this slide? So there are 2 kinds of incorrectness. One is syntactical, one is contextual. So syntactical incorrectness can be caught by that, but contextual incorrectness, for example, you are using a wrong Helm chart altogether. You are using a quota that is not there in the namespace. You are using a different strategy that can lead to downtime. For these things, we have some heuristics, some validations that we add. So that was my talk. I only have, I think, 2 minutes for Q&A. So do you have? I don't have. Okay. You have? Okay. Sorry.
So anyone who have questions, you can come down to the mic over here, and then you can ask your questions.
Yep. Okay. I have? Okay. Yeah, I'm open to Q&A now. I've covered. Okay. I think no questions. Oh, okay. Yeah.
Yeah, so am I audible?
Yep.
Yeah, you said like in the production environment, when you deploy, the 10% of the requests are routed. Is those requests are like duplicated or the actual partitioned 10% thing?
Partition request. So there are things, so right now, the demo that I showed, the requests are partitioned, but you can do shadow traffic as well. So how it is controlled? It is controlled using STO. So the load balancer that we have at Flipkart, it is also called ELB, just like AWS ELB. It has STO stack embedded in it. So all the traffic routing rules, we modify it there, and it routes the traffic accordingly.
Okay, even like the 10% can be
Yep.
configurable, right?
Yes.
No more questions.
I think they have.
No more questions.
No. Oh, you have a question? Okay.
You mentioned there is a job partitioning between short running and frequent jobs versus there are long running jobs. So how, when a job or something comes up new, how do you determine where to place it, or is there a?
So if a new job is there, it goes into the short running pool, because that is a larger pool. Once it runs for the first time, then its score is generated, and depending on that score, if we require to change the pool, we change the pool. So that is how it works.
Okay, got it.
Okay.
So in your deployment variant in the flow, I saw that like there is KATS as a workload, but I believe you also have a VM deployment option.
Yeah.
So can you talk a little bit about that?
Okay. So VM right now it is. So how do we do VM deployments? Is so. Thing Ansible to deploy to VMs. So Flow also has Ansible support. So the templates that you saw earlier, I'll just open the templates here. I'm able to. Yep, I'm able to. So these are the messages we show, and if you go to catalog, you'll find that I have Ansible template. I think there's another. We have Ansible template. So you can just create your Ansible scripts in your GitHub repo, check them in, and you can set up a pipeline that uses this to deploy to VMs. Now we also have a generate inventory step, which will just look at your tenant ID, and it will generate the inventory dynamically for you. Also, we have a cloud CLI that is like Google Cloud CLI, but for Flipkart Cloud, that is used to provision VMs and maintain them. So again, that is again available as an environment here, and you can use that. So that is how VM pipelines are set up. I can show you a pipeline in demo that has this. We have, yeah, so for example, this pipeline is provision VM pipelines. It will clone the repo that has your Ansible scripts. It will provision the VMs. It will delete the VM. So you can do anything here if you're creative. So that's the standard practice here. But those VMs that are created, they are treated as a first-class entity in another platform that handles VM. It has yet to come on Flow. So that is called capacity planner that people use. But yeah, that will come to Flow in some time.
Yeah. Hey, you told that you have multiple stages in your pipelines, right? So is this a state machine, or like how are you maintaining the state? Let's say there is an error in one of the states, right? how do you know that, okay, this is the state and I have to roll back or roll forward from here? Let's say there's a temporary issue or something like that.
So yeah, it is not a state machine per se, but if there is an error, so a step is successful if it does not, if it is not exiting with code 0. If it is exiting with code 0, then the pipeline fails. There are retry mechanism, but they are manual. We don't retry them. We don't retry them automatically. So that is how it works. But before something is applied, it is vetted first. So if there is some error in the DAG itself, it doesn't go into execution. But if it is going into execution and failing for some other reason, for example, build failed because your code didn't compile, the pipeline will fail, and you will get a notification that it failed because of so and so error. Then you can rerun it. So that is how it works, because like you can do any use case here. Flow is just a way to use arbitrary hardware we have on worker pool. But what we are using it for, we are using for CI/CD use case. So in that case, there is no point on retrying something that is failing with a code compilation. So that's why we just send a notification and someone retries it.